The Open Data Center Alliance is really focused on user-driven requirements. So they're producing specifications that say, here's what we would like to see for standards in open computing. There are multiple working groups. There's a services working group that says, here's what I'd like to see my service providers to go do. There's a management working group, security, etc. So there's various domains that they're putting together to set requirements out there. What open compute is really about, and by the way, sorry, I shouldn't neglect one, there's an infrastructure working group, which is how do I, as I deploy cloud computing, make sure my infrastructure is manageable and has a level of consistency. The Open Compute project is really a design and kind of engineering-focused effort where people are putting together the IP. So when you look at the link between that infrastructure working group that says, here's what I'd like to see, and then a group that says, by the way, here's what we're designing, it's a great marriage. And that's really what we kind of kicked off is the 300 group set of users who are saying, here's what we want to adopt, with this group that's really focused on the design and the engineering, the specification, and they're working together to make that happen.
Well, yeah, and I would add to that we're, as a group, the Open Compute project is 100% focused on the physical infrastructure around servers, storage, and data centers. And the ODCA has a different charter around cloud computing standards. So just a different focus as well.
And all of languages, ODCA is a very wide range of users, 300 plus, whereas the focus is clearly on dev scale, large scale data centers in particular.
You guys could introduce yourselves as well.
Tim Prickett Morgan at the Register. We're talking about servers and data centers. What about switches?
Yeah, so let me try to address this.
We
do believe that focus is really important to accomplish stuff, and the initial focus certainly is on server storage in the data center because it's the vast majority of the spending and it's a problem that needs to be solved. There was some discussion how networking and network fabrics relate to that. And quite frankly, networking is a much harder problem, even in terms of 100 years of, not 100 years, tens of years of specs and hundreds of specifications and protocols that and so on. Now there are important innovations to be made in networking relative to large-scale web things and microservices or others. So we look forward to contributing these eventually, or even as part of this process. But it is just not the focus of the initial community, which is to solve the burning problem of how to build a more efficient data center.
Thank you. Paul Mooney, Neuron Spark. Welcome to New York.
Thanks.
Most companies give two reasons as to why they haven't as yet moved to the cloud, and that's speed and security. So will you alleviate those worries?
So if I could jump in there, one thing that may not be totally clear, when I talk about cloud service providers, is that these same racks can also be used by enterprises to build private clouds inside the traditional data centers. So the benefit of what's going on here will also translate to those customers that want to build large, cost-effective, power-efficient kind of data centers going forward. And with OpenStack on top, you can run an Amazon kind of service in your own data center, right? So there's a whole separate movement of where is it justified for people building their own data center, or where they're better off renting cycles from Amazon. And it's really only the customers who have the larger scale and 24/7 requirements that should build their own data centers. But for that class, the same technology can be used.
As a matter of fact, I think one of the contributions that I neglected to mention during the main presentation is companies like Nebula, who are using OpenStack and building a cloud appliance on top of it to enable exactly what Andy was saying, which is building out private cloud infrastructure that strives to have the same speed and ease of use as Amazon services.
Yeah, I think you're going to find most of the members that are part of the NCP also have a relationship with someone who's doing things like OpenStack. For Dell, we announced an OpenStack reference about 2 months ago. And so I think the ability to take those pieces and put them together is valuable to bring as well.
I'm Robert Scoble from Rackspace. I visited C-Micro recently, which uses the Atom processor, and they claim that they use a quarter of the electricity of other approaches. Is open compute going to go down that road, and can they? Because C-Micro is a proprietary system, right?
Yeah. So I mentioned earlier. By the way, I think there's probably more opportunity than we've got lots of appetite. We obviously have only so much we can kind of shovel at any given point in time. I mentioned that we in particular have a strong interest in microservers, and we've talked amongst us about the concepts of what might architecture look like for a lot of these very small distributed systems. In fact, Andy and I have been talking about concepts of this for probably 4 or so years of what some of those things might look like. There are some additional specifications out there. Obviously, C-Micro's got a very specific and a very interesting type of approach. I do think that the real work, and it's not necessarily something that may be an immediate solution, but something that may be a project we take down the line is what could a even larger scale microserver type of solution or architecture be? And I think at the appropriate point in time when we have enough bandwidth and we solve some of the things we currently have on our plate, I think that's a good thing to take.
It's one of the things that we're excited about with OpenRack. So we shared the OpenRack specification with folks like C-Micro, Calzeta, and others that are in that microserver space. And today they're trying to design typically around kind of legacy chassis that we've developed for legacy, or I shouldn't say legacy x86, but hotter x86 processors. And when you think about what they might be able to build at a rack scale, when you look at some of the really cool fabric management stuff that they have, being able to do that fabric management at the scale of the rack instead of enclosing it in a sub-chassis, their excitement really started to flow there.
How about patents? Because they claim they have lots of patents. And I visited a data center in Las Vegas who was sort of pissed that Facebook stole some of their ideas. And we're thinking about suing about our patents. They have patents on some data center designs that Facebook supposedly copied. What's the patent world like in the data center world?
In the data center world?
Yeah, I mean, if you want to use a small microserver.
So the goal of this project is open everything. People who contribute the information as part of the membership agreement as they will also yield their patent rights to the benefit of the community and not sue each other, etc. Right? So I think we want to develop these things going forward in a way that's non-controversial, let's just say, and hope to stay out of the patent wars. I hope it doesn't come down that somebody wants to patent physics of airflow or something like that. I think it can patent nature, if I remember this correctly.
those nesting systems are pretty popular for that field too. It's true.
Julie Sinoff from Ohana. First of all, I think you broke the rules of the glass house by simply using the building of free air. But, the big issue, of course, is people who are used to the glass house mentality and have migrated and stuck to the quote-unquote recommended window. There's still an embedded, mindset that's going to be tough to beat. I think people can understand the temperature window creeping up slowly, but a lot of people are really comfortable with the window. Are you going to be basically publishing failure rates at the end of 12 months to get a sense of, did you get any humidity-related failures? I know Intel's got the proof of concept out there with, but on a mass scale like you're doing, obviously that's one of those places where humidity over the course of time may turn into something that people are concerned about.
One thing to keep in mind is these Azure recommendations date back to the 1960s or 70s when people had punched cards or magnetic tape and they were worried about the magnetic tape sticking the wrong way, things like that, right? We're far beyond this. There's no physical media that need to be protected in this the environment. And it is true that whoever built a data center in the last 20 or 30 years and follows recommendations are not going to change it, right? What's built is built. The opportunities for new data centers that are much more efficient at the large scale to question and essentially throw out all these assumptions and looking at the reality behind it. And the fundamental advantage that Facebook had and Google had was that their platform group was not focused just on the server, but the entire design problem, which is how do you optimize the power for the whole thing? And you come up with a different solution if you do that than if you just look at the one or two use server. And this is the essential advance here.
And I'm just going to add, I think the other thing is sort of the resiliency through software. I mean, there was a time where you had to worry about every individual server going down and what data was on it and the like. And the way I think a lot of things are being architected today is that there should be no single point of failure, not from the hardware or data center, that sort of thing, but from the software itself. So if you have that kind of mindset, and there is some sort of fallout over an earlier time frame, is that really it really goes more a cost trade-off than it does in failure trade-off.
And just one last thing is, the Azure consultants and the Azure folks that they do good work, but they want lots of margins of error and they don't want any callbacks, meaning they don't want to go back there if anything goes wrong. So by design, it's almost over-provisioned, over-designed, and over-spec'd, and over-expensive. It's not optimized. And you can't, because there was not enough of a uniform assumption on loading per rack and power distribution and so on. So again, the fundamental advance is to solve the problem at the data center level, not just at the individual rack level.
And I think some of the intelligence that hopefully the group will provide is that it's sometimes not as easy as just opening the window up and letting the air come in and it's done, right? There are certain things obviously that need to be done. And I think, some of the research that we've looked at is even if you run it hot, if you run it too hot, literally the components themselves start to consume more power due to the thermal resistivity. You actually offset the benefit from it. So you have an optimization, effort that needs to take place. I think we've got enough talent and intelligence here that hopefully we'll be able to provide some of those best practices in design.
I think the last thing that I would point out here is that the important thing is not just us sharing all of the successes around how efficient this can be, but also sharing where we do make mistakes. And if we do see any drop-off in the longevity of the machines, or one of the things that we're sharing today in some of the technical breakout sessions is, humidity is not bad, but if you have made a mistake with your building management systems, which we did, you may end up having condensation on some of your components. Now that's not good, right? Now, and then we're sharing with the community the mistake that we made and how we worked around it. But those are, I think, equally valuable to all of us saying, hey, here's the best way to do it, but also the mistakes that are made along the way.
And you made a good point that I think that we should touch on too. A lot of this stuff really has been overcome. If you look at the way most people specify lock servers today, they're 15 to 85% relative humidity non-condensing. As Frank said, the non-condensing is the humidity. But most of this, I think one of the opportunities that we have is to show where it got is you're being too conservative. If you got some margin, go ahead and take advantage of that. And I think that's one of the key things that will come out of this.
And last point, it does benefit certain locations more than others. So the Pacific Northwest looks pretty good. Countries like Sweden and Norway and Finland, there's a location advantage to the ambient cooling that cannot be ignored. Canada looks good.
Going back to the patent, Kevin has some mission critical. I had a kind of a two-part question. One is for the hardware manufacturers, how do you go about incorporating technological advances gained from the community without opening yourself to accusations of patent trolls and whatnot?
Well, I think one thing to keep in mind is that most of the elements here have been open standards for the last 20, 30 years. Open standards meaning there's PCI buses, there's CPUs, so not that the guts of the CPU standard, but the instruction set is perceived to be the industry standard, etc. So there's a long history of standards that are getting rolled up here. What has been missing is the system level standardization that as of so far has made every system end up doing slightly different choices, which meant replicated investment and customers who ended up with different bits in so many places, right? So that is a problem that just needs to be solved for that particular community. And it's not kind of the smartphone, patent war here. So you cannot compare this to what's happening in the wider space where, people have 10,000 patent portfolios and they're trying to prevent each other from market access, right? We're just trying to solve a problem here that is a real problem that exists. That's one of engineering optimization and just sane business practices that have a mutual benefit to both the vendors and the customers. But it's not the kind of thing where, there's some magic patent for a heatsink that's better than the other heatsink that's essential for purpose here. So I don't see the patent angle really.
I was going to say the other thing is that a lot of the standards, sort of served as a basis, sort of a demilitarized zone, if you will, to allow people to do this. So again, the interface doesn't become a point that prevents people from being. So having a history of standards and specifications is good. Normally those things have been done under a reasonable and non-discriminatory type of license, so people can use it and adopt to it, but they may roll a royalty or something like that down the road. What's been kind of innovative about open compute is it's royalty-free, so it's the idea being is get people to contribute stuff that you really want to proliferate to the industry and really make it as frictionless as possible to allow people to adopt it.
There's some, second part, there's some tension between the Facebook descriptions of opening best practices up or even advanced practices and discussion about standardization. So within your organization, what does the discussions look like in terms of what are we going to share and where are we going to draw the line in the rest of this proprietary?
From a Facebook perspective, we believe that
the organization.
Yeah, I thought that was more directed at the hardware supply base, but from a Facebook perspective, we certainly, and I pointed this out during the presentation, this community is going to thrive by making sure that it's beneficial not only to the consumers of the technology, but the suppliers of the technology as well. Now, and I can't speak on behalf of Intel or Dell here, but there are certain things that are absolute differentiators for them, and those should always remain their intellectual property. Right? They are true, innovative, differentiating technologies that they have. There are other areas where I think we all need to do a group hug and say, let's stop this, this unwanted differentiation with everybody trying to come up with a different way to instrument a certain motherboard so that we have to write extra software to manage it across this whole fleet and things like that are just the unwanted ancillary bits around the true IP.
Yeah. And sorry, just to add, kind of the analogy I used, I think sort of describes at least our philosophy around it, which is, the engine and the engine compartment. I mean, people and vendors ought to compete on really delivering the best product, not because of some sort of perceived moat or non-value added differentiation. I think that kind of goes with what Frank said. So if you think of the engine, having a better engine is somebody's IP. So if Dell delivers a better engine, then they ought to get paid for that better engine, and they don't have to publish the spec of what that engine is. That said, it really shouldn't be about the size of the engine compartment or some proprietary way that it goes to the drivetrain. So the APIs themselves are the place where I think it's important to have standards and allow the user to have interoperability, but it shouldn't mean that every piece of differentiation that a vendor can innovate upon has to get published out. Otherwise, there's not much vendor incentive.
In the networking space, for example, even though networking is not the focus here, the only networking protocols that have been successful in the history of networking has been open standard networking protocols. Different vendors have implemented them and raised the market in different ways. So if there's a way to, for example, improve management through the network here, that will be an open effort. There's no intention to add any proprietary features here. But it has to be open so everybody can participate and actually find a solution and then it benefits the whole community.
And I think Dell recognizes that too. That's a big part of the OCP. It doesn't mean we're going to dump our entire patent portfolio into the OCP. But it does mean those things, as Jason and Danny pointed out, that really aren't critical value adds, but become more of a hindrance perhaps to us moving forward. As otherwise, that's what we'll bring to the table. We're understanding what it is we're going to deliver now.
Hi, Rich Miller from Data Center Knowledge. The open compute obviously goes just beyond servers. You've got UPS designs, cooling designs. There's a fairly substantial ecosystem of power and cooling vendors out there. Is there a role for them here, and or the offerings out there adequate to suit the needs? And has there been any outreach to those companies?
Yeah, there's definitely a role for everybody in the community. I think what we're showing today is kind of the tip of the iceberg on the engagement that we've been able to have over the last few short months. And clearly most of the contributions that you saw were in the form of server storage type technologies, but there's absolutely a role for any of the power and cooling suppliers or any other types of componentry that goes into data centers. I think that'll probably be the next wave of contributions that we'll see.
Jim Raposa from Information Week. A lot of the discussion, you pointed out yourselves that obviously the genesis of this came from scale computing. It looks like a lot of the initial benefits or the initial implementations will be in scale computing. How quickly do you see this going down to, obviously not hobbyist type levels, but if I'm building a tiny little data center, just a few hundred, maybe 1,000 servers, how do I benefit from these types of technologies, or how soon do you see some of this trickling down to the people building data centers that aren't quite to the level of Amazon or Facebook?
I actually think it's more dependent upon the types of workloads than on the actual number of computers that you have in the environment. So I think that the approach that we're taking here and the technology that we're opening is most applicable for people that have software workloads that scale horizontally. And whether you have 10,000 or tens of thousands, I think it could be a fit. That's one of the other reasons I'm excited about some of the enablement of the community with Hive and with Dell here to be able to take these technologies to customers of all sizes.
So if you could add to this, the current rack is quite frankly optimized for the large scale data center. I don't think it's exactly UL where you might approve because he might was in the building level fixing. But the point is, there will be a future version of a rack with the front door that's EMI approved, right? So there's a few things that need to get done to be able to deploy these things in the conventional, smaller scale data centers, but that I think will happen shortly.
Closing off again. One simple technical question: why the triple rack, not just the 3 discrete racks?
Well, and that's a very good point, right? In a normal data center, maybe a triple rack is really hard to get through the door, and what the building needs is a single rack version. Okay, so the triple rack was optimized again for very large scale deployment, but I would bet you're going to see single rack versions as well.
Using the spec off the triple.
Using the same spec.
Yeah, so, I mean, the reason we originally designed it as a triplet as opposed to a single was to, number one, eliminate the amount of material needed to put 3 racks together, because obviously when you use singles, you have more physical material, which adds more weight, which adds more shipping costs, which burns more fuel, etc. The other thing is just when we deploy, at least at Facebook, bringing in 3 racks with a couple of people is faster. James was showing some pretty amazing statistics on how fast they're deploying capacity, and so speed and agility and the ability to put a lot of capacity on the floor very, very quickly was also critical. But we also heard from the community that I can't even get this through my door, right? I'm in a leased facility. This isn't compliant from a height perspective. And so actually with the open rack spec that we're sharing today, not only a triplet version, but also a single version as well.
Now my philosophical question is, you push PUE down to nearly, perfect 1.0. From 1.07 down is really just a, the wonderful
We won't be happy till it's 0.9.
Right, of course. But that brings us to 0.9. Obviously, PUE can't go below 1 by specification, but the green grid basically allows for PRE and PUE. And in this vast ecosystem that you're trying to perfect, do you see the next sort of milestone for you guys as you start to look at taking the megawatts that are going out to the doors heat instead of obviously using mechanical cooling, but now just still rejecting it into the air? Do you see that your next inside your milestone window to see if it work?
We're currently using that exhaust heat to keep the rooms at a reasonable temperature, right, during the colder months, for sure.
You can heat the facility in Norway.
Right, I know they're doing it in Norway, they're doing it in Greenland, they're doing it in Iceland, but I didn't know if this was part of the...
It's hard to recycle the heat, unfortunately.
Yeah, recirculating that heat is absolutely part of the specification.
The building is easy, but for other purposes.
Yeah, it's recovery of energy.
There's a couple of ways that probably do make sense, and it will get you to a PUE of less than 1, in that you have more power being applied to the servers because you're using the waste energy for other things. Things where waste heat might make sense are growing high-value crops in climates that don't make as much sense. For example, tomatoes are a super high-value crop. Growing those near the Canada-U.S. border, you can do that, for example. So there's some ways of doing it, but it's a challenge.
But anything that we...
It's truly green, exactly.
You're going to have a rack accessory for tomato holders?
Yeah, we need a triplet rack for tomatoes, exactly.
We can turn off all the microwaves.
Actually, what I'd like to do is take the heat water with it.
Yes.
Cold water park in Iowa or something, charge $15. People come to do the hot water, pay for things that way. I like it.
Hi, Craig McSweeney from Information and Financial Services, and this question is for Don at Goldman Sachs. So as a financial services firm and more of a user of technology, 2 questions, I guess. Why did you feel it's important to join the Open Compute project? And also, what will Goldman Sachs contribute to the project as it moves along?
Sure. Well, I think, at Goldman, we do quite a bit of building technology, using technology, but we're certainly not at the level of hyperscale that some of the colleagues are at. But when you look at kind of our business, it's fundamentally driven by technological innovation, and we have a large amount of engineering capabilities, a large amount of software development internally, and we run it at almost like maybe a mid-scale lab where we have a pretty large global footprint that continues to be driven up. So we invest quite actively in many of the objectives that the foundation is focused on. We work very closely with the technology partnership to really understand how we can drive consistency across our partners. We look at really driving down the cost of ownership. I think places where we think we can contribute is that we do run in a business that's both highly regulated. We run a business that tends to be more mission critical. So finding ways to run those types of workloads in a much more cost-effective scale way is kind of where we end up being at the center of our expertise. And so we think that there are places that we can help contribute both from a configuration perspective, but also in terms of an asset perspective. We're going to have people here today from our team who are going to lead the system management conversation as an example, because that's where we do need to ensure we can build critical management solutions around commodity type hardware configurations, and we invest in building our own software, which could potentially be something we end up contributing as an asset into the foundation.
And actually, in some areas, when you think about the challenges that Don and his team deal with, because they've been in business and deployed technology for longer, obviously, than Facebook has, they actually have a multi-generational systems management issue. And so they bring a lot of value to the table, something that Facebook will run into in the future as we have multiple generations with different ways to remediate firmware or different ways to push updates or monitor systems across a very wide-ranging fleet. So it's really great to have the Goldman team, the Goldman technology team as well, focused on these kind of things, because they bring a different perspective, one that we might hit years down the road of, wow, what do we do now with all these different generations of systems?
And one reason to hold this event in New York was actually there's a surprising amount of interest on the side of the financial services interested in these kind of developments.
Excuse me, Matt Eastman from IDC. This is going to kind of continue down the same theme, which part of what I hear today is a transition from a focus on the organization on IT as a business type organizations to organizations where IT is a major point of differentiation. So kind of back to Don and Goldman. But you also start to see that the needs of an organization where IT is not just a business are quite different. So you have mission critical workloads and hyperscale workloads. And what you start to see is differentiation in the data centers and also in the IT architectures that you're using. And I'm just wondering how you balance that. So you have two different types of data centers emerging. Do you have the picture that James showed earlier, on one hand, and also with kind of a Prinville type of data center on the other?
We did, and to Frank's point, because we've been in this business and technology has been such a huge, fundamental driver of the financial industry for a very long time. We have a little bit of, museum where you'll see things that were built 5-7 years ago to things that now are out there that are very cutting edge. But, we've always built our own data center facilities, so we have design and engineering teams. So you'll see, examples like Andy's data center. We'll probably have 1 or 2 of those. But we have, examples where we're building either, very modular, high scale oriented like the Frankovsky facility. And we do a lot, within the community, both within the financial community and much more now broader across the technology of just sharing best practices and learning from each other. That's a big part of what we see value from the foundation of the community coming from is that it really does help address. Everybody has different types of problems they're trying to solve, but at the core, the ability to learn from each other has been a critical value equation for us.
So are they walled off from one another? I mean, it gets into kind of risk and governance and so forth.
Well, we all, part of our business and where we think we can help add value is how do you manage some of those challenges? How do you manage security challenges? How do you manage the needs to segregate information from each other in a way that can also be done scalably? So, some of that is, a lot of that's at the logical level when you get kind of above, the server or the data center. But, more and more with modular technologies, there's ways to help use that to really help, drive an investment process that supports that as well. So those are places where we think we can help contribute.
Hi, Dave O'Hara from Green Data Center Blog. Actually, I have a question for Red Hat. Part of the vision of the OCP server is a new hardware SKU that's out there. So I'm curious from your perspective, like if you imagine like 20% of the install base of like new goes out, what do you think from a Red Hat perspective that would change things because there's a standard open hardware out there?
Yeah, I mean, a big part of what we do is enable great ideas to be consumed. So, by joining early, it gets us to not just sort of ensure that Red Hat works really well with the new platform designs, but, we have a client base from exascale computing all the way into FSI and enterprise. And so if there's innovation happening here, but it's really expensive for them to be able to deploy it because it ripples all the way through custom operating systems and changing application stacks and changing how your system's managed, then we kind of fail. So the whole idea is to be part of this every step of the way so that as soon as it starts to solve an IT problem, that IT can consume it at zero cost. Really, that's our goal.
Eric Smalley, Wired.com. Is there any thought being given to tracking deployments and collecting data? And if so, what are some of the performance, financial, and environmental metrics you're going to be looking at?
Yeah, so we do publish, currently from a Facebook perspective, we publish our PUE on a monthly basis. And obviously that varies with seasonal outside air conditions. But I need you to clarify the question about tracking deployments. So those are kind of the outputs of the you have a different thought on that.
As companies move into data center from components that are OCD.
You mean tracking these type of data centers from a market share standpoint?
No, meaning,
Or just an adoption standpoint.
adoption.
Yes.
Use.
Yes, absolutely. I mean, that's, contributions and adoption are the two critical real measures of any success of an open source project. So we will definitely be talking about, for those who are, approved through their PR departments, we'll be talking about people that have adopted open compute technologies.
Anybody else? Last questions?
If I decide I want to do an open compute server, how do I do it? What do vendors have to do? Can I use the brands? What's the process?
As a consumer or
as a company?
Vendor. Yeah, vendor. So if I want to go create another variant, what's the process by which the project is? Yeah.
If you want to branch the spec.
No. Branch the spec. Just build another motherboard server.
Right, the project.
So you understand.
So I think, basically there's a mechanism, and I'll up a little bit. But basically, if you want to do another project, let's assume you see one of the specs and say, this is great, but I want to go do something different. Are you talking about, I'll cover both things real quick. If you want to go do a new project, not something that's an already existing kind of motherboard, but you're going to do a variant, you propose that project through the community, and there's a means by which the community will review the project and then sanction and approve it, that sort of thing. So you can create a new spec. That's that process for that. If, for example, you say, you know what, I like that particular spec that already exists, and I just want to build a process for it, you build to the spec. And I think one of the things that we're still discussing a little bit is what exactly is the mechanism by where somebody, if they want to use the logo to say this is an ODC compliant motherboard.
Not to sort of get ahead too much, but nobody's prevented from adding anything they want, right? I think if you want to build a GPU motherboard for this rack, go ahead and do it. Nobody's going to slow you down. However, what you may want to do first is to talk to some of the key customers, like a Facebook, to see if they want that or what's your audience for that, right? So I think what vendors will do is they want to engage with customers and figure out what is missing, what value can they add, what areas should they focus on, and then projects will get the attention naturally gets focused on the stuff that's new, relevant, and important going forward, right?
So as you can tell, we're still trying to kind of figure this out as we go.
I'm just wondering if there's an open compute brand
logo compliance problem.
Yeah. One of the really challenging parts of this is just to make sure that not everybody just starts putting the open compute logo on everything, and then it just gets diluted and it means basically nothing. So we are developing a methodology so that suppliers can come in and we can have an objective criteria in place for, is this supportive of the core tenets of open compute? If yes, then we'll apply the trademark, and then we'll have that distributor sell it under the open compute brand.
And there's many levels of standardization, right? There's the rack, there's the way the board goes to the rack, the power connector, right? So if it's compliant with that, it sort of fits into the standard open rack, and it could be a board that's just a unique board, right? So there's not a black and white kind of boundary here.
So you could do PlugFest at one point in time, conceivably. Do like PlugFest?
Yeah, so again, the details of some of this stuff, and it's something we're discussing because there's definitely shades of gray. At the base level, if you just wanted to design to the spec, it's royalty free, have at it, it's there. If you wanted to go say it's ODCA compliant, that's the thing we're trying to figure out, is there's different levels of PlugFests or compliance tests or certification, and how does that all work? By the way, I mean, to Frank's point, we always love feedback, right? So if the community has a strong feeling about how we go do these, I think it's time to give us that feedback, and as part of the board, we're going to go figure out the right way to.
And again, most importantly, all the approved specs are published on the website, so anybody can just download them and get going, right? So we're not trying to slow anybody down here.
People who sit in and judge what's a new project, what's not, how the composition of those groups are determined.
Okay. Yeah, I'll start, and I'll let Andy comment a little further. So, The first step is anybody in the community, whether it's a student in university, a small medium business, one of my web skill peers gets engaged with a project or wants to start a new project, they'll bring it to the incubation committee. The incubation committee is still forming, but we envision that to be about 9 people from diverse areas of the business, from data center storage, servers, etc. Andy has graciously agreed to be the chairman of that committee. And then that committee will work to make sure that the project has a proper charter, specification, etc. And then those projects, based on their merit of the project, will get promoted to the board of directors to be voted on a quarterly basis.
Yeah, so the idea is to be very inclusive. In other words, anybody can propose a good idea. No, the ideas that advance are the ones that customers actually want to deploy and that there's a relevance for them in the market, right? So there may be ideas that one officer that can build at some university that still fit in the same rack, and there's other ideas that become the mainstream, full socket motherboard next year, whatever. So it's a wide range of things that can go into a common power cooling rack infrastructure.
So the leadership, if you want, in that regard, is drawn from people who represent companies that have paid dues of some sort, or become members in that way?
No, there are
there's no dues. There's no dues.